Hi, I'm going to show you how to use the OSPF Hello Packet, how the OSPF Hello Packet establish the neighbor relationship between each other. You see, when we create one we topology, it's router 1 and this is router 2, and they are going to establish the one OSPF adjacency relationship. Right? OSPF, we know we are going to use the command route OSPF 100, right? Then router, then network 1.1.123.10 0.0-225, and router 2, same thing happen. I'll use same command router OS 100, then network interface 1.1.123.0 20-0-255, air number. Okay. Okay, the neighbor relationship is established, right? So you can see this the system message. Okay, and also all OSPF neighbor, you can see the neighbor relationship set up. Full status. So let's see what is it looks very easy, but what is the happened in the background? So we use the pocket analyzer to see what we catched in the pocket. Topology. When we use the command router OSPF 100 and the network command in the process, so we established I1 R2 the OSPF adjacency. Okay, so then we can see they are transferred packet between each other from the interface. They are transferred packet between each other from the interface. Okay. So first, let's see. Okay, the first package is here. They send the first packet. They send the first packet is here. The R1 sends the hello packet to R2, which is IP packet. Okay, the version IP packet combined with the OSPF packet. So what is the included that the differential service field? There's the first 6 bit is 30. Class sector is 6, and the total length is 84. And the identification is a 50 file flag, right? The TTL is very important, is 1, and OSPF EIGRP, the protocol ID is 59. So let's see the source destination. Okay, let's take a look the OSPF path first. This packet, what is happening? Have 3 parts. The hello packet has a OSPF header, and OSPF hello packet, and the rest of the data block. All right. So let's take a look at the OSPF header. Okay, version, and this is a message type. Is type 1 is hello packet, and the packet length. Okay, the source IP. This is the IP such as the person's name, right? So this is the router ID. Okay, they choose the highest low back. The router ID is. Okay, they are in the backbone area 0, and the checksum and the authentication in the hello packet, they have authentication field. So once the header part, okay, authentication in the OSPF part. Okay, let's take a look at the hello packet. Okay, in the hello packet, there is section must be specific, exactly same. So the two routers can establish the adjacency. One is the subnet. Okay, for example, this is R1 has the subnet is of 255.255.0. The other side of the routers must be the same network mask. The second one is the hello intervals. For this one is hello intervals 10 seconds, so the other side must be 10 seconds to establish the relationship, the adjacency. Okay, and there is another field, and is that intervals is 40 seconds. Also, they must be the same as the other side. Okay, so they can establish so 1, 2, 3. This 3 field must be exactly same, so they can establish the relationship, the adjacency. Okay, and this is designated router, which is the response for sending and receive all the data LIC link state link neighbor. All right, so that means they have two active neighbor. Right. Okay, this is the hello packet. Okay, once they send the hello packet, right, the other side. Okay, this is the hello packet. R1 sent through the OSPF router. Okay, this is 224.0.0.5. Okay, and this is sent to the this 2.0.6 is used by the DR. Okay, so let's see the next one. Then this R2 send back the hello packet. Okay, they also have the same information such as the version number in the header. Okay, hello packet type 0, type 1, and OS source area, and not authenticated. In the hello packet, they have this must be the same. Network mask and hello interval, and that interval must be the same. Okay, which is DR, because they do not know which is DR is BDR. Right. So after you send the hello packet between each other, so they are going to the two routers, and so goes into the two-way status. Okay, we call two-way status. So sometimes we use the command show IP OSPF nib. We can see their two-way status. That is not a stable status. Finally, it will become a full status. So after these two packets, they're going to send each other the DB descriptive packet. Okay, they send the DB description, they exchange the database information between each other. That they exchange what is different between each other. So make sure their database are the same, exactly same. Okay, let's take a look what is in the DB packet. Okay, this DB packet. Okay, this header. Okay, this type 2 message type 2, right? DB's description source, right? Okay, description, MTU interface, MTU. Okay, this have this code, and also they have this information here. All right, so and also R2 send R1 the same their database information. So after the exchange information, okay, they're going to send LSA update information. Okay, and acknowledge information. So finally it become a full status. Okay, so they have a request packet. All right, so usually the first package is a hello packet sent between each other. First package is a hello packet, then DB described between each other, then LOS request packet is a message type is 3. Okay, then also the update message. Okay, the type message type is 4. Okay, and finally is acknowledge message, which established the full relationship in the Ethernet network. Okay, this is the this is the packet. The packet is sent between each other, and once we use the command router OSPF to establish the relationship.